Thank you for joining me today, and thank you, of course, for joining this ENOVIA NetVibes user conference in Netherlands. It's not too far from your own country.
No, not at all. Quite close, and it's been a really fun, exciting event. I've met lots of people, learned a lot of things. It's been really good to hear about the transformative nature of how ENOVIA and NetVibes have helped companies transform their operations, and actually seeing a lot of synergy between the journeys other companies have to our own journey that we're really just on the beginning of.
Yeah, no, you made also a brilliant contribution to the event with your presentation yesterday. So again, thank you for that. So maybe can you tell us a bit about yourself, who you are, I mean, who you work for?
Yes.
And
yes.
what is your top in mind motivation in what you are doing?
Yeah, absolutely. So I'm Jonathan Keep, and I'm the Concept Integration and Development Manager for the STEP program working at the UK Industrial Fusion Solutions Limited. And what we're doing is we're developing a first-of-a-kind fusion power energy plant. So the idea of that is to take principles that have been demonstrated in experiments such as JET and other machines around the world, and trying to turn that into a power plant, a way of putting some power onto the grid. And no one's done that yet. No one's got to the point where we can actually put power onto the grid. And so from our point of view, it is taking the scientific principles that we've developed so far and making that pioneering leap, that delivering fusion energy as an industry for the future of power for the world.
So simply you want to harness the power of the sun,
Absolutely.
Put it in
That's right, yeah. So as I explained in my talk yesterday, fusion is at the heart of all of our stars and is a source of all the energy. And so what we're trying to do is recreate that inside a magnetic bottle that then enables us to generate energy in a means that is low carbon, and so gives us that sort of sustainable future and a view to sort of transforming some of our energy infrastructure
and keeping it under control.
Yes, yeah, and keeping it under control. And it's interesting, the sort of control piece. I've had a lot of comments about the temperature. Mm-hmm. So if you recall from the talk yesterday, we were saying, so at the center of the machine, we're at 150 million degrees. Now that temperature
impossible to even realize what it means.
It is, it's absolutely crazy. It's 10 times the temperature of the sun. But actually, that seems really scary. But at that sort of temperature, we're not talking about a lot of particles that are at that temperature. The density is relatively low. And so although there is quite a lot of energy in the machine, actually, if you stop looking after it, it just stops. It doesn't. Nothing else kind of happens. It's not a critical thing that leads to a big catastrophe. Fix it and restart and carry on.
So we all feel better. So it's a first of a kind. It's a product that will take decades to realize in this industrial version, and then it will be operated for as well decades. So
yes,
I guess that this has it's the first of a kind. So you will have to manage all this. This is a huge information to manage. Many people at the end to connect. So I mean, what are the implications on the selection of collaboration and life cycle solution?
So that's where the platform of 3D Experience has been really valuable to us. It's that being able to integrate data from all sorts of sources. So no matter whether it is within the sort of ENOVIA and NetVibes environment and bringing in those capabilities, but also looking beyond that and understanding how we have to connect with partners at all sorts of levels, whether it is a supplier of a discrete component, a pump or something like that, or a major partner that is delivering a whole system. We need to be able to seamlessly and smoothly and efficiently share data with them and be able to incorporate their data into our models. And what we've chosen is the sort of 3D experience platform as an enabler for us to do that. And that fits into this larger infrastructure, which we're calling our Plant Information System, or PIMS for short.
I remember this term, PIMS. You know?
Yes, yeah, and it's not just a cocktail drink. It is actually for us the core of our information and our data, and that's critical for lots of different reasons. So the first outcome we're looking for is delivering that demonstration fusion energy plant, which is really cool, really interesting, really important. But the value that we get out of the program isn't just about the plant, it's about the industry that you're enabling as a result of building that. And that needs the data, needs the understanding. We need to have created a path that we can follow again and again, understood all of the tests, how those results feed simulations, how we merge that data together to inform sort of future virtual models, and then we use that knowledge to enable us to design better plants, which become the commercial sort of fusion power plants of the future that we want to be able to deliver. And that information is like our crown jewels. It's so precious. So we have to have a platform that will look after it for us and create that digital legacy that we can then hand on to the future.
You are in the early stage of this long journey, even if you already started several years ago.
Yes.
And as you said, you are the architect of all those systems. So are there some principles? What kind of guidelines, or what are you using to architect this overall system?
So at the moment, the challenge we've got is the understanding of the systems and how they need to behave is in the preserve of deep specialists with lots of experience and understanding of fusion and how that works. And that's great. But for us to deliver the plant, we need to be able to decode that and hand over pieces to companies that maybe don't have the same level of fusion expertise and experience. But we still want them to deliver our own systems here. So what we have to do is we have to use model-based system engineering as a means of decoding that.
Organizing it.
Yeah, that's right. So what you're taking is you're saying, well, what are we trying to deliver? How does that create systems within there? What's that function analysis? And at the moment, we're in the process of using the CATIA Magic tool to create system models that enable us to understand what exactly are we designing. And it's really interesting in certain areas with work on other experiments such as ITER and other devices. We end up in this trap of thinking we know what we're trying to design, but actually when you start modeling it, you then ask those new questions, which you go, well, so why does this? What is this system? Why is it here? What is it actually doing for us? And in doing so, you then reinforce those requirements and you make sure you really understand why those systems are there. And in doing that, you also maybe can identify opportunities for innovation where you say, well, this is the conventional system, but maybe we can merge these functions, or we can take this function and put it over here. And that sort of functional analysis
is a place for innovation as well.
Yeah, it's hugely powerful, and it enables us to identify some opportunities for some really good innovation that enables us to push forward and accelerate that development.
And to have clear interfaces definition.
Absolutely, yeah. And ultimately, we want to get into a space where that system architecture is stable and we understand it. But at the moment, there's a piece of understanding the art of the possible, understanding what we want, bringing those things together, and then identifying those gaps and saying, well, okay, what technology, what's the opportunity that we can do something interesting here? Is there something we could develop which potentially has IP or potential for future developments? And that's where it's really exciting. That's the sort of pioneering part that keeps me interested and involved. Is sort of understanding what those. There's lots of similarities to the Apollo program. It is that kind of going, here's this problem, we need to solve it. There is nothing that exists to solve the problem, so let's invent a thing. And then you never know where that goes. You know, what could you do? Having solved that problem, what else can you do with it? Well, that's where it becomes interesting.
Yeah, and also, as you mentioned, the fact that you will have also to connect and to integrate all the ecosystem around this. So it's not just about yourself. So.
That's right. And by developing those technologies, working closely with partners who maybe have expertise in those fields, and they then, we provide some stimulus to say, look, we need this thing to perform this function. You're doing something over here. Can you stretch towards this? You're then enabling that growth, and you're enabling those industries to thrive and maybe develop things for their own future as well. And that in itself provides that sort of wider economic and social benefit beyond just developing a power plant.
In this conference, we introduce this Gen 7, concept, trying to on this ambition, because again it's a vision, it's an objective.
Yes,
we have to put all the pieces together, and working also, of course, with customers to create those 3D universes. But again, the virtual twins, generative experience, virtual companions. Knowledge know-how platform, and of course cycle of life, which is quite important in your case. Again, how does it resonate to you?
I think it resonates a lot in terms of our perspective. One of the things we've been trying to do is thinking. So we're looking at a program that's going to run for a decade or so. So you have to then look forward, not just to say what can you do with today's tools, but what could you do with the capabilities in the future. So when the performance of your desktop PC is equivalent to a current data center, you then start saying, well, okay, in that world, what could we do? And that connected landscape of bringing together all of the different data sources, building these models, and true twins of big facilities such as ours, we've got to have that in our ambition. And what I see in the Gen 7 platform is that same sort of ambition to try and say, well, okay, we've modeled the systems, we've modeled the components, we've dealt with how they fit together. Now let's get the wider landscape, get the whole, think about the system in a true holistic fashion, rather than just in a container. That to me resonates so strongly with what we're trying to do with the way we're looking at building that ecosystem, that digital ecosystem that enables us to do some amazing things for the future.
Actually, you are taking, as I remember, a critical step in this direction. I think you have decided to transition to cloud.
Yes,
which is coming pretty soon. Can you tell us maybe a bit more about why you decided that, and what benefits you expect from this transition?
Yeah, it's interesting. Yeah, we're moving on to cloud later this year, and I'm quite excited about it in the fact that we've been standing up the initial capability, and what we've ended up doing is having various things being built. So, for example, with the system engineering team are working heavily in the model-based world in CATIA Magics, and what we really want is those very close live connections between the data that's generated there and the data that is stored in 3D experience for the requirements. And what we get from cloud is that connectivity becomes seamless and it becomes together. And so what we're looking to is actually trying to make sure that when we build that connected infrastructure and we create that sort of digital framework, those connections are as easy and as smooth as they can get. And that's what the cloud is offering us, is that ability to connect in lots of capabilities that otherwise we may be able to do something, but we almost get them, not quite for free, but you know what I mean. They're so embedded in the platform, it becomes very easy for us to just say, we need to build this. So we've got all our core data. Now we're using, costing data, and it fits directly into the tool set for there. We want to understand our carbon footprint and do that carbon accountancy, or we can bring those capabilities in and directly connect. That's hugely valuable. And not only is it being able to do that, but the speed of deployment of new capabilities is then really exciting, because we're able to just bring in those things pretty much out of the box and start using them very quickly.
It's impressive, your ambition to be as agile and fast for such kind of a long-term program. So you need to keep some clear short-term milestones to keep everything moving.
That sort of agility has driven us for the early part of the program. We've recognised that we have to have that agility. We need to come up with a hypothesis of what our design might be and test that and fail fast, and then try and change and make those decisions. And that's, again, where that sort of model-based approach becomes really valuable, because you then start understanding the right questions to ask, and where are those really important decisions that then enable you to make those big steps in progress of what you're actually defining. And you've got to accept that we'll make a few wrong decisions. And so you're better making a decision, testing it, finding it is wrong, making the change and positively bringing that in. And culturally, we've worked quite well with managing that, because we're on this sort of early pioneering stage. We have to make sure that we've explored the options.
Yeah, and then you will be able to take the full advantage of all what is being done around these generative experiences and take to do the best possible usage of all this data that you are going to assemble in the system. Yeah.
That's right. So if we're storing all that data, you get that sort of big data lake of all of the things that we've tried, all of the decisions and the options that we've poured. Then in the future, when we're trying to understand how to do it better, what's the next one, you've got all of that history to pull on. You understand where your decisions have come from, what were your key points. And when you're going to do the next one, the more optimized design, you've got that history. You're not having to dig through archives in a library somewhere and go, why, what was, who did this? Where does this number come from? All of that sort of legacy. And I've worked on programs where it is, okay, I need to know about this system, and you have a box of files that's 20 years old, and you're going, I have no idea what this means.
Maybe.
Yeah, that's right. And you're going through looking for a needle in a haystack to try and just find that nugget of information. If we can create a digital thread that you can pull on and find your way through and understand those questions of, well, why did you use this factor? Why did we end up making this key decision about the architecture? What was this function for? Being able to pull back on that in a digital sense, that makes that future work so much more efficient. It's I'm leaving a present for my future self.
We can see, and your passion is your passion is contaminating. I was looking for my word. So, but Jonathan, thank you very much for your for this passion, of course, for attending our conference. I think people were very amazed and impressed by your session.
And thank you very much, Stephane, for inviting me along to talk, and for a great conference and a great product as well. So.
Okay, I'm sure that we will meet each other again.
We will, yes,
Thank you very much.
Indeed. Thank you, Stephane.